mod 4 counter. What does that mean? It counts by 4. So if we start with 0 initially, next state is going to go where? What's 4 more? That's 4. Next state, 8. Next state, 12. Next state, well, if we don't hexadecimal, the states are what? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's 4 of them. 0, 1, 2, 3, 4. So 0, add 4, 1, 2, 3, 4. At 4, add 4, 1, 2, 3, 4. Add 4, 1, 2, 3, 4. Add 4, 1, 2, 3, 4.
Back to 0.
Back to 0. So this goes back to 0. Now what happens if you state 1 then? If it's 1, it goes to 5. It goes 4 more, which is what? 9. It goes 4 more, which is it 13? 13, 4 more. 1, 2, 3, 4. Back to 1, right? How about if you had state 2? Because it could end up being there. 6, 10, 14, 1, 2, 3, 4. Back to 2. And the only one left is 3, right? 7, 11, and 4 is what? 15? And after that, 15, 1, 2, 3, 4, back to 3. So it depends where we find ourselves. If you're counting by 4, it depends where we are. So when we do our state diagram, we're going to set up actually here 16 states, 0 through 15. So how many flip-flops we're going to have? Remember, 2 to the power of the number of flip-flop has to be greater than or equal to number of states. The number of states are what here? 16 from 0 through 15. That's 16 states. So 2 to what power is greater than or equal to 16? X will have to be 4. I have to use 4 flip-flops. And let's mix and match. We already used S. We did the D. We did the JK. We didn't do the SR, right? Did we do the SR? No. So maybe we'll use SR flip-flop.
Is that 4 seconds, or what is it counting by?
Which one?
4. That 4. MOD 4 count.
Counter.
Counter. What does it count?
Counts by 4.
Counts by 4. What does the 4 stand for?
No, I just picked the 4, the number 4. I want to increment by 4 each time. I could have made an increment by 3.
Is seconds or?
No. Like with the state where you are. If you're state 0, you know, these numbers, if you find yourself here, where to go next?
Okay.
So to go next, it goes 4 more, whatever that number after that. If you're here to go there, 4 more after it. If you're here to go 4 more, which is right there. That's what I'm telling to do. It's not time, it's not, there's only like a switch, a clock comes in, it looks and sees where you are. If you're at state 7, for example, it says, okay, the next state should go to, if you're at 7, is what? 11. If you're at state 9, the next state should be what? Then 13. If you're at state 8, the next state should be what? 12.
Now are those ups or downs?
Well, we can make, it depends on the flip-flop that we have. Does it go on the rising edge or on the falling edge? So now I got to do my truth table for that. This lecture is almost redundant what we did last time, except a little bit different. So I don't know if I'll put it up there. So maybe you want to take some notes. So I have current states. And I get 4 of them now because we said 4 flip-flop. I get Q1, Q2, and what? Q3 and Q4. I do not have any external input. The only thing I have is the clock. The clock comes in, it says if you see this clock, if it depends where you are, go right there. This is the next state. We'll call that Q1 naught or asterisk, whatever. Q2 asterisk. Q3 asterisk, the next one. And Q4 asterisk. If you are state 0, 0, 0, 0, the clock comes in, according to this one, where you want to go? State 4, 0, 0, 0, 1, 0, 0. That's what 4 is, right? Zero, 1, 0, 0 is 4. If you are state 1, 0, 0, 0, 1. The clock comes in. You want to go where? 5, 0, 1, 0, 1. Do I have enough space to skip one for each one? Maybe. If you are state 0, 0, 1, 0, that's state 2. The clock comes in. You go to 6, 0, 1, 1, 0. If I'm a state 3, 0, 0, 1, 1. 3, the clock comes in, it goes to 7, 0, 1, 1, 1. If I'm a state 4, 0, 0, 1, 0. The clock comes in, we go to 8, 1, 0, 0, 0. 0, 0, 1, 1. Did I do the right one here?
No, I think it's 1, 0, 0, 0.
Okay, 0, 1, 1, 1. That should be 1, 0, 0, and 1, 0, 1. Yep. That's state 5. I'm still in my head trying to calculate if I have enough space. I don't think I do. I have to go every single spot. I'm a 5. I need to go where? 9? 1, 0, 0, 1. If I'm at 6, 0, 1, 1, 0, that's 6. It should go to 10, 1, 0, 1, 0. If I'm at 7, 0, 1, 1, 1. That's 7. The next one is what? 11? 11, which is 8, and 3 is 11. Now the next one is 1, 0, 0, 0. That's 8. 8 will take me to 12. 8 and 4 is 12. The next one is 1, 0, 0, 1. 9. 9 takes me to 13. 1, 1, 0, 1. Next one, 1, 0, 1, 0. 10. 10 takes me to 14. 8 and 4 is 12, and 2, that's 14. 1, 0, 1, 1, 8, 10, 11. If I'm at 11, I go to 15, which is 1, 1, 1, 1. 4 more states. If I am at 1, 1, 0, 0, that's 12. Where is 12?
Brings back to 0.
To 0. 1, 1, 0, 1. 13. That takes you back to 1. 1, 1, 1, 0. 14 takes me back to 2. And the last one, if it's 15, 1, 1, 1, 1, it takes me back to 3. So if you actually get inside one of these, you're stuck there. You'll never get out of it. You know? If you end up with 0 initially, you'll never make it to the 1. Unless some crazy stuff happens. Bad signal or something, you switch to 1. But normally, if you're stuck inside that one, it goes 0, 4, 8, 12, 0, 4, 8, 12, 0, 4, 8, 12 all the time. But what happens if we have some lightning now, boom, and that signal jumps to 1? We got to cover for that. Or it jumps to 2. Or one of the bits somehow went wrong there, and you find yourself 2. You got to cover what's going to happen here now. That's why you have to list all the combinations. Now we're going to go through our SR flip-flop and see what the excitation table for the SR flip-flop. Remember, the SR flip-flop, just like the JK, except when it's 1, 1, don't use them. We have that somewhere. I think the first flip-flop we looked at it is the SR flip-flop. SR, here we go. 0, 0. Stay the same as Q. 0, 1, it's 0. 1, 0, it's 1. 1, 1, not allowed. So let's look at the, oh, come back here. So let's look at the SR flip-flop. Q next. 0, 0 stay the same. Same as previous. Same as current, whatever it used to be.
The S, right?
Q. If S and R are 0, 0, Q next will be the same, whatever it used to be, no change. If it's 0, 1, that's a reset. It will go to 0. If it's 1, 0, if you put 1, 0, it will go to 1. Doesn't matter what the previous one was. And if it's 1, 1, that's not allowed. If you look at it, not allowed. So the excitation table for that, Q to Q next. What is S and R should be? If you go from 0 to 0, that could happen 2 different ways. How do you go from 0 to 0?
The same as previous. So 0, 0.
It could be 0, 0, that's one way.
And or 1, 1, right?
0, 1 also will make it go to 0, because that's a reset.
0, 1.
So it's going to make it 0. So as long as S is 0, it doesn't matter what R is. You can see as long as S is 0, R could be 0 or 1. This is 0 and don't care. So as long as you put 0 here and you don't care what you put, you can make it 0, 0 or 0, 1. Either way will make the next state 0. From 0 to 1, it can't be this one. See that? It can't be. Because you're not staying the same. You're changing. It can't be this one because that will make it what? 0. It's not 0. It's the only way that will happen if it's what? 1, 0. Let's look at 1 to 0. 1 to 0 again. You're not staying the same, so that option is out. I'm going over these because I know on the test I'm going to give you a flip-flop you've never seen. I'm going to make my own flip-flop. So I expect people to be able to go from here to there. Figure out what these are. So that means it's not staying the same. Could it be 0, 1? That will make it a 0, right? Because it will make that state 2. Could it be 1, 0? If it's 1, 0, it's going to make the next state what? 1. It's not. So nope, the only way is what? 0, 1. And the last one, what about 1 to 1? Well, 1 to 1, it could happen if you make S and R 0, 0. Because because you're staying the same. Or, how about this one? If you put 1 and 0, what will happen to the next state? It's going to stay 1. So as long as R is 0, S is what? Don't care. I can accomplish that. So that's the excitation table for the SR flip-flop. Now I gotta use that to see what these values should be. Let me look now at this column. And compare it to that column. That's the first flip-flop. So this is S1 and R1. I have a flip-flop for the first one, S1 and R1. Let me put a line to separate them so I know that's the first flip-flop. So let's look at it. 0 to 0. Let me look at that sheet here. 0 to 0. What do you want to do? 0 and don't care. 0 to 0. 0 and don't care. 0 to 0. 0 and don't care. I like this when they're the same. 0 to 0. 0 and don't care. 0 to 1. 1 and 0. See that? 0 to 1. 1 and 0. 0 to 1. 1 and 0. 0 to 1. 1 and 0. 1 to 1 for the next 4. 1 to 1 is don't care and 0. Don't care 0. Don't care 0. And the last one, don't care 0. And the last group from 1 to 0, what is 1 to 0?
0 to 1.
0 to 1. So that's the first flip-flop. Now let's look at the second flip-flop. S2, R2. And now let me highlight that with different colors so I can look for it. That's the red column with the red column. I'll use red for them. 0 to 1. Again, 0 to 1. 1 and don't care. 1 and 0. 1, 0. 0 to 1. 1, 0. Oh, 1, 0, right? Put in the wrong place here. 0 to 1. 1, 0. 0 to 1. 1, 0. 1 to 0. 0, 1. 1 to 0. 1 to 0. 1 to 0. Is that 0, 1, 0, 1, 0, 1. Next group, 0 to 0. 0 and don't care. 0 and don't care. Then 0 to 1. 1 and 0. 1 and 0. And the last one, 1 to 0, which is 0 and 1.
Wait, why is it 0 don't care and 0 don't care? It's 0 to 1, 0 to 1.
0 to 1, 1 and 0. Where is that?
You're,
Oh, these are all 0 to 1?
yeah, it's all 0 to 1. I think you might have been looking at the first
I probably was looking at something else. 0 to 1, 0 to... They're all four the same thing. That should be the same. 0 to 1. It's 1 and 0 for all of them. Yeah, I must have grabbed this one. What about the other ones? Did I... They were good?
Yeah, that one should be fine, because
Yeah.
I got
Okay.
like 1 to 0 for the first
Yeah.
4, 0 to 1 for the next 4,
Yep.
1 to 0, and then 0 to 1.
Now let's look at the next one. Let's pick a different color now. I don't know. Blue here. Third flip-flop. Let's see if I can keep my fingers on it. 0 to 0, 0 to 0. The first two. 0 to 0, 0 and don't care. The next two. 1 to 1, 1 to 1. 1 to 1, don't care, and 0. Then 0 to 0. 0 and don't care. 0 to 0. 0 and don't care. Where's my finger? 1 to 1, 1 to 1. Don't care, and 0. 0 to 0. 0 and don't care. 0 and don't care. 1 to 1. Don't care, and 0. Don't care, and 0. 0 to 0, 0 to 0, 1 to 1. 0 and don't care, 0 and don't care, and don't care, and 0.
Move it up when you get a chance.
And the last one, I'll make it thick one. That's this one with that one. So that's the fourth one. S fourth, R fourth. Let's look at it. Hopefully I don't screw things up. 0 to 0. 0 and don't care. How many of them? Oh, next one is 1 to 1. Don't care, and 0. 0 to 0. 0 and don't care. 1 to 1. Don't care, and 0. 0 to 0. 0 and don't care. 1 to 1. Don't care, and 0. 0 to 0. 0 and don't care. 1 to 1. Don't care, and 0. 0 to 0. 0 and don't care. 1 to 1. Don't care, and 0. 0 to 0. 0 and don't care. 1 to 1. Don't care, and 0. The last four. 0 to 0. 0 and don't care. 1 to 1. Don't care, and 0. 0 to 0. 0 and don't care. 1 to 1. Don't care, and 0. And now K-map for each one. Build it. Done with it. I need 1, 2, 3, 4, 5, 6, 7, 8 K-maps. 8 of them. One for each one of these. So maybe I'll do 4 per page. Q1, Q2, Q3, Q4, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. This is for S1. I have another one for R1. Q1, Q2, 3, 4, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. This is for R1. I'll have another one for S2 and R2. S2. Q1, Q2, Q3, Q4. So let me do the first 4 columns. Then we'll see. This is S1. 0, 0, 0, 0. 1, 1, 1, 1. Don't care, don't care, don't care, don't care. 0, 0, 0, 0. Oh.
Do you still have to skip that out?
Well, I know it's going to be the same, so that's why I didn't skip it.
But you do, right?
Yep.
Okay.
Because they're the same thing, so I don't have to skip it. Next one, R1. 1, don't care, don't care, don't care, don't care. 4 of them. 4 zeros. 4 zeros. 4 ones. Then S2. 1, 2, 3, 4 ones. 4 zeros. 4 ones. 4 zeros. Should be a nice one to build in the lab. This is not bad at all. R2. 0, 0, 0, 0. 1, 1, 1, 1. 0, 0, 0, 0. 1, 1, 1, 1. To read this one, it's only one group, right there. Q1 naught, Q2. To read this one, Q1, Q2. To read this one, there's 8 of them. These 4 with these 4. What do we have? Q2 naught? To read this, you group these 8. We have Q2. Now I gotta do 4 more of these. Then I'm ready to build it. Let's do 4 more K-maps. Q1, Q2, 3, 4. This is S3. R3. We might do this in the lab. It looks like it's not that difficult to build. It's not a lot of gates. There's no external input. Unless I encounter something more fun. S4. By the way, you can use a ROM for these. You can use PLA. You can use decoders, multiplexers if you want to. You can still mix and match. I'm just trying to build them using just connection and gates. And let's see what we have. Going back to S3, 2 zeros, 2 don't cares. 0, 0, don't care, everything. like this. 0, 0, don't care, don't care. 0, 0, don't care, don't care. What's the smartest thing to do here?
Nothing.
Make them all zeros.
Oh, we can-
If you make them 0, what's S3? 0. Attach it to ground. Next one, don't care, don't care, 0, 0, and it repeats that thing. Yep,
Do the same thing, make it 0.
yep. You could, if you want to, you could actually just take these guys and group them as 8 ones, you know, if you don't want to ground it, because just taking a wire, either attach it to the ground. Notice, if you take these guys together, what are you doing?
Only getting one end.
Q3 knot, right? So either take a wire, attach it to the ground, or take a wire, attach it to where? To Q3 knot. What difference does it make? It's just a wire. Where do you attach it? So this is not making it, says, well, aren't you supposed to pick like all 16 of them, like make it, isn't that a better approach? Well, either way, I'm just attaching a wire somewhere, either to this end or to that one. Do I plug it in this hole or in that hole in the lab? What difference does it make? And let's look at the last two. 0x, 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 0x. There we go, the same thing. And again, it's really up to you. I'll just be different, just to make it different. I'll attach these guys together, make them ones, and they'll be what? Q4. The next one, x0, 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 x0. I'll take them all together, and that'll be 0. So I'm having fun with it. Right here, I can either go or attach it to ground. The same thing, or ground if you take all 8 of them. You know? So it really doesn't matter. This again, you can do ground, or you can take the top 8. Because if you take these 4 with these 4, you'll be attaching it where? To Q4 knot. And this one, if you don't want to attach it to ground, if it's too far from you, you can take these guys or Q3. So you can do either one for all these 4. Now time to build it. I have 4 flip-flop JKs. I have one more sheet here, lined paper. I have more, but I'll use that one. I need to get like one of those rectangular shape, like a plastic, we just put it, makes the whole thing for you, instead of using the ruler there. I know they sell them. So I can make my shape quickly. This one too high here. That's the first flip-flop. So it's number 1. This is S1 and R1, Q1 and Q1 knot. The next one. Number 2, and it has 2 input, S2, R2, Q2, Q2 knot. The next one. Do we have gates in the first group? This is Q3, Q3 naught, S3, R3, this is number 3. And the last one, S4, R4, Q4, Q4 naught. Now we have a clock here that's going to operate, could be on the rising edge, could be on the falling, I have no idea. It depends what we pick there. So, but it has to be synchronized, the clock attached to all of them. So this is the CLK, my clock. And again, it could be working on the rising edge, could be on the falling edge. The way I'm drawing it right now, on the rising edge, because there's no bubble there. And what's attached to S1 and R1? Where was it? S1, it's an AND gate of Q1 naught and Q2. It's an AND gate of Q1 naught and Q2. This is Q1 naught. I'll make it a little bit short here. Need some space. Make it look nice, a little bit nice and neat. Q1 naught. And what's the other one? Q2. By the way, if you're going to do this for a living, that's what you have to do when you design them. That's what engineers do. We don't actually build them on a board, we build them on paper.
And we send them somewhere.
Yep, that's the first one. It's going to be like this. So you have to be nice and neat so they can read it. Now R1 is an AND gate with Q1 and Q2. I already have Q2 here, which is this one. So let me extend it just a little bit. And now I'm going to have Q1, so let me move this up there. And when you cross these, just don't put a dot on them. They know it's not attached there. That's S1 and R1. Notice the dot here. I put a dot that tells me it's connected there. There's no other dots yet. Now S2 is easy. And R2. R2 is actually Q2. So here's Q2. To R2, you're going to attach Q2 here. Attach it here, notice. And this is what R2 is. S2 is going to it what? Q2 naught. There's a Q2 naught. So let me move it one space out. Oh, I went too far with it. So now we got the second flip-flop connected. Just a wire. Now the third one again, you can either attach it to ground or Q3 for S3. And the same thing for R3. Ground or attach it to one of S3 and was it Q3 and Q3 naught. Make my life easy, I'll just make a wire here. and both go into it, and that's ground. And what is S4 and R4? I can do the same thing. I can make my life easy the way they're drawn here and attach it to ground. And now there's my design. As you flicker the switch, and that's your clock. The clock, you'll see the stages, the lights actually lighting differently. If initially you start with 0, 0, 0, means none of them is on. When your clock comes in, and you know from the lab you can adjust the speed of the clock. When the clock comes in, where is it initially we start with? I'm missing a page. Oh, right here. If you start with all them being reset, it means 0, 0, 0, 0. They're all off there. And the clock comes in, it goes to 4. So you'll see off, off, on, off. Then the next one you see 8. Off, 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 on. So off, off, on, off, that's 4. Off, 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 on, that's 8. The clock comes in 12. Off, off, on.
So it works as 1, 0, 0, 0,
Yep,
0.
binary, yep.
Binary.
Yep.
And the Q1 is the highest one, so 15.
Yep, the way I drew them, that's the one on the left. That's the most significant. Now, if you decided, you know what, I'm going to reset this, reset that, set this to 1, and that's 0. Because remember, there's a reset and set on them, each flip-flop. So if you start with 0, 1, 0, 0, that means you have a 2 here. As the clock comes in, if you start with a 2, where's the next move? 6. So you're going to see this and this on, these two off. The next one is going to be 10. This and this on, these two off. The next one is 14. This, and this on, that's off. So depends where we start with.
As it loops, it changes. As
Yep.
the number changes.
It depends where you start with. Because once you're inside one of these loops, there's really no way to get out unless you do something to make it jump. So if you start with everything being reset, you're going to see it 0, 4, 8, 12, 0, 4, 8, 12, 0, 4, 8, 12, the whole time.
No, this one's on the rising edge, right?
Well, I don't know. I mean, the picture I drew, yes,
Yeah.
from the
What if
picture.
it's on the falling edge?
Well, it does the same thing, just when the clock goes down. You know. So the way I drew this, that works on the rising edge. As the clock goes from 0 to 1, you'll see the changes. If it's on the falling edge, you see the same changes, but when it goes from 1 to 0.